everybody. I just thought I'd put this little video together about working with limiting reactants in stoichiometry. Um, I know that this is a next step in what we've been doing, and if any of you were absent on the day that we started this, or if you feel like you'd like to get a little bit of a refresher on what we learned, please watch this video, okay? Up to this point, we have always been working with limiting reactants, but it's always been really obvious because one reactant was always given to us in excess, you know. So if one reactant is in excess, then the other reactant must run out when the reaction stops, or the reactant runs out and makes the reaction stop. So now we're not making it as obvious. We're given the amount of the reactants, and we have to figure out which one of the reactants is going to run out first. When that happens, the reaction stops. That's the limiting reactant. In other words, the limiting reactant is the reactant that limits the amount of stuff we can make. All right, let's try a sample problem here. We've got a really simple chemical reaction here. We're making water by bringing hydrogen together with oxygen. And I'm going to start with a BCA table. And I'll start with the kind of a problem that we would have been working on up to this point, just to really make you understand exactly what I mean by how is this next kind of a problem a little bit different, okay? Let's say we were working with a problem like before where, let's say I was given 4 moles of hydrogen with excess oxygen, and we're making water. We haven't made any water yet in the before part. Now, when we run this reaction, we're going to use up all 4 moles of hydrogen, and we'll end up with none in the end. We'll use up 2 moles of oxygen, but we just have excess oxygen in the end. How much water would we make? We would make 4 moles of water. That's the kind of problem that we would have worked on before. Now we're going to switch it up a little bit. So I'm going to change what's given now. Okay, this time let's imagine that we were given 1 mole of oxygen. Not excess, but 1 mole. And now we have to decide which of these reactants are we going to run out of. So which is going to be the limiting reactant? So let me try a certain scenario here. Let's see if we can use up all of this hydrogen. If we used up all the hydrogen, we would end up with 0 hydrogen. Now, how much oxygen would I need if I was going to use up all of this hydrogen? I would need 2 moles of oxygen, right? For every 2 moles of hydrogen, I need 1 mole of oxygen. And if I try to use 4 moles of hydrogen, I'm going to use up 2 moles of oxygen. All right, but you can see that that's impossible. I can't use up 2 moles of oxygen. I'm only given 1. I can't end up with a negative amount of oxygen in the end. So clearly this is impossible. This can't work. So let's try this again. All right, so now I know that the hydrogen cannot be the limiting reactant. In fact, we're going to use up all the oxygen. We'll end up with 0 oxygen. How much hydrogen am I going to use if I use 1 mole of oxygen? I would use 2 moles of hydrogen. It's a 1-to-2 ratio. So for every 1 oxygen that I use, I'm going to need 2 moles of hydrogen. In the end, we'll have 2 moles left over of hydrogen. I'll just call that excess, or EX, whatever, it doesn't matter. Okay, and now how much water can I make? Well, for every 2 hydrogens that we use, I can make 2 waters. We used 2 hydrogens, so I can make 2 waters. And in the end, this is what we've got. Okay, so that's an introduction to working with limiting reactants. And we have to find the limiting reactant in order to know how much stuff we can make. Okay, so let's try another one. Let's try another problem. Okay, in this problem, I'm given some calcium, and we're going to combine that calcium with water. We'll make calcium hydroxide and hydrogen gas. All right, so I put together a BCA table here, and I'm just saying in this problem, we're given 5 moles of calcium and 7 moles of water. Before the reaction starts, we haven't made anything, so that's 0 and 0 for calcium hydroxide and hydrogen. Okay, now I want you to be careful about something. There could be a misconception out there that might say, oh, well, since 5 is smaller than 7, then calcium must be the limiting reactant. Well, let's not say anything about that right now, but let's be careful about that assumption. Okay? Why don't we start thinking through what we're given and which must be the limiting reactant? Okay, so let's say I was to use up all. Hold on. Let's say I was to use up all 5 calciums. Okay, how much water would I need to use up all that calcium? 5. Let me start over again. Let me show you. This is a 1 to 2 ratio. If I'm going to use 5 calciums, I'm going to need 10 waters. And that can't be possible. I cannot take 10 out of 7, right? So water is not going to be the limiting reactant. Let's try this again. So let's see if water is the limiting reactant. Let's use up 7 waters. If I use up 7 waters and the mole ratio is 2 to 1, I need half of the calcium that I have of water. Half of the calcium. So if I'm going to use 7 moles of water, I'm going to use 3.5 calciums. 3.5 is half of 7. Okay? And then I'm going to end up with 1.5 moles of calcium in the end. That will be in excess. And this is our limiting reactant. So how much stuff can we make? Since for every 1 calcium, I can make 1 calcium hydroxide, and for every 1 calcium that I use, I can make 1 mole of hydrogen, both of those answers are going to be 3.5. It's a 1 to 1 ratio. For every 1 calcium I use, I will make 3. For every 1 calcium that I use, I will make 1 calcium hydroxide. For every 1 calcium that I use, I will make 1 hydrogen. So if I'm using 3.5 calcium, then I'm going to make 3.5 calcium hydroxide and 3.5 hydrogens. And that is the answer. So that's how much stuff we can make. We can make 3.5 moles of calcium hydroxide and 3.5 moles of hydrogen. So again, if you missed class when we introduced this, please make sure that you've watched this video. And if you are ever confused by this, go back to this video and see how this makes sense. Okay, it's going to get better with practice, so that is why we're going to be working through a bunch of worksheets. In the future, I will probably make videos of myself solving some of those worksheet problems. All right, take care, everyone.